Does it not show if you F11? Okay, there we go. Okay, so tonight we're going to talk about code golf, which is kind of an esoteric element of program development. Like, this isn't something that an expertise would be needed to do anything that's actually meaningful in life, but if you are really good at code golf, that makes you um, like objectively cool in the eyes of others. And so one of my goals in life has been to get really good at code golf so that I can make a lot of friends. Um, so, and really, Logan beats me at this too. So, like, even after all the amount of hours I've put into it, I can't beat him at a single thing. Okay, so what is code golf? Code golf is basically the minimization of source code byte count. And there's different types of code golf based on language. So if you're writing like assembly code, then it's not byte code based on how many characters, but it's byte code based on what the compiled assembly byte count is, or what the compiled hex code byte count is. But then in C, it'd be more like how many characters can you put within your C file, and how far can you minimize that. And then the lowest score is what wins. And so this is where you get the golf term into the name. So usually DSU challenges have been written in C. There's this presentation's been copied throughout the year, so I think there actually is a set of holes that's written exclusively for x86. And then I think at one point there was some interest in writing some Python challenges, just because there's a lot of really neat inline Python syntax that you can write, and so we thought that'd be really cool. I don't know if that's been added or available anywhere, but online you can really find any sort of language and any sort of challenge that's prevalent within the language. And then you even have languages that are like primarily built for code golf. So there's like this language called Jelly that's insanely good at code golfing. And then there's some other really weird, like C code golf is this weird interpreted language. It's kind of C syntax, but you can do a lot of like tricky things to reduce byte counts. And then this last line develops low-level understanding. I think one of the primary reasons I was really interested in code golf is because you understand all these kind of like one-use tricks that you'll probably never use before, but it like engages your understanding of the language. So there's no real need to understand how a ternary works in C, but as you start using ternaries, you like start to see how control flow works a little bit better, and you like see the compilation and assembling more clearly, because the compiler is like it's really smart. It does a lot of cool things, but it only does what we tell it to do. And so as you start to understand more of what these languages do, you you understand a lot more about why it is that the developers of the language made it the way they did. Sometimes you think that it's really weird why they chose to do things, and as you become good at code golf, you can make fun of them for that. Okay, so we're going to hop into like a ton of, or not even not a ton, but a few tips and tricks primarily for C, and then we're going to go through one example that's like a kind of interesting example that's been in a challenge before, and then I'm going to show off the site where you can do some of these, and then I'm going to pose a challenge for people to do that. So it won't be that terribly long of a night, but I think it'll be hopefully a little bit interesting. Okay, so all of these tips will be for C. Like some of them you can apply across different languages, but for the most part, it's pretty language dependent for the sorts of things you will want to cut down bytes within. So for example, in C, whitespace is almost never necessary. But then in a language like Python, whitespace is extremely critical, because whitespace determines how far you're tapped into a code scope, and how functions are defined and what the function will return. All sorts of things are defined by whitespace and things like Python. But in C, whitespace almost never needed. So the two cases I've found that whitespace are required is if you're declaring a variable and you have to distinguish the type from the name. So if we were to make an integer variable called var, you can't just name it int. You can't do int var with no space, because it'll try to it won't know how to parse the string int var. It just knows how to parse int, knowing that it's a type, and then how to grab what the label for the variable is after that. And so this space is really required. However, the compiler knows how to parse things like int star, because int star will define an int pointer, and then you can put your variable name after. So if you can somehow save bytes later by treating your variable as a pointer the whole time, then you can do this trick and then save your one space byte, which is, I don't know how often that would ever be useful, but and then the other case that I found that whitespace is needed is after an else statement if you're not adding curly brackets. And so if you've got something like, and we'll bring this in from time to time. If you've got like an if and then your case and then an else, and you decide to, since you can have a single line that's not within curly brackets, you have to have a space between this value and this value. You can remove that space if you're adding curly brackets, again, just because the front end part of the compiler can figure out that it needs to be parsed and split here. But here it doesn't know what to do, and so it tries to treat this as one single statement. And so those are the only two places that I found spaces are. Oh, and also go-tos. That's the last thing that I found. So if you want to go to a label, which like I really wouldn't recommend for the most part within CodeGolf, just because go-to is always 4 bytes, and like, I don't know, it feels like you can have better control flow without having to use 4 bytes. And then you also have to create this label somewhere, so that's automatically 2 bytes. So within these, you also need to have a space. But otherwise, you can basically just cut out spaces. Like white space is basically useless within C because it's removed by default anyway. So, okay. White space is done. Okay, so from like 150 to 250 to 300, and then, branching off there, whatever development path you had to take if you're still writing C, this is a really common found skeleton for all of the code that we would write. Primarily because it sets up a lot of convenient elements for how the compiler looks for, or like this skeleton is really convenient because it has parts to it that we can memorize and then like reuse often. So like if you wanted to include argument parsing, then you don't have to handle the way that main is grabbing arguments from like libc star main. You can just have your variables defined, grabbing them off the stack here, and then you don't have to like refigure out how to do these things. So like writing the skeleton like this becomes really convenient. And also this return code. Main returns 0 by default, but having the return here, I mean, is a simple way to remind yourself how to change the way main returns so that you can handle that on off cases or something. But in CodeGolf, there's rarely ever command line args, so you don't really have to worry about that. And return codes don't matter because we're not like scripting this out or caring about what a return code is anyway. There might be cases where main is calling main itself, and then you care about what it returns. But for the most part, it's never really that big of an issue. And then this int in front of main doesn't matter either because by default main returns an integer too. And so again, like the skeleton's here, and we add the int because it's important to treat functions homogeneously. And so as we create new functions, we know how we treated main, and so it's like appropriate to continue using the skeleton. But in CodeGolf, you can just write this. And so like the biggest jump in bytes will be the first time that you convert a nice looking program into something where you've dumped new lines, white space, and made main look like its most bare bones, the most bare bones that main could look like. And I think for the most part, if you're not including undefined functions, this won't actually give any warnings or errors, just because there's a lot of default behavior that main already produces. But if you're starting to incorporate prints or something without including libraries that would be required, If you start doing that, then you'll get some error messages. But for the most part, GCC will let you get away with a lot. Okay, so that's our new skeleton. We don't have to have white space. Okay, while loops. So this, I guess you could say this is more of a pet peeve within CodeGolf, but I think there is probably 0 scenarios where a while loop is appropriate, just because you can do everything in a while loop and a for loop, and oftentimes save bytes, because for is 2 less characters, and then you can do a lot more within those 2 characters too. But if something doesn't make sense written as a for loop, then I suppose you could convince me that a while loop is necessary, or not necessary, but convenient. But for the most part, you can just write your for loops like this, and as another example, we can say while thing is less than x. That's actually identical to saying for, and then treat this initial loop phase as nothing, and then treat the like the iterative loop phase as nothing. And then all you have left is this check. It's treated identically to this while loop. And then, like, let's say you wanted to initialize variables, or you wanted to change variables, you don't have to include any more semicolons. Like for is already fewer bytes, or equal bytes, and then it sets you up to save bytes also. So this is why I think while loops are stupid. And you could probably make arguments as to why they make sense in a lot of cases, but I just wouldn't agree with you, because it just doesn't make sense to me. Because you've got to save bytes to look cool. So, okay, so white space is useless. Skeleton should look like that. For loops instead of while loops. Okay, this one is a big one. If statements are most of the time worthless, because ternaries both save you bytes and they make you look way smarter. So the only thing that's a little inconvenient within ternaries is that you can't use statements like goto and return. You can only use expressions, which is kind of interesting. I don't know if there's really... Actually, I think you can return. You just can't goto. I don't know if there's really any scenarios where this stops you, but it's something that we found. I think I was talking to Alex Durr about this, and we tried to incorporate a goto into a ternary, and there was an issue with left var being a statement instead of an expression. Because I think the reason is because the statement has to evaluate to something for the ternary to work. I think you have to have full evaluation, and the expressions always evaluate. That's maybe why. But anyway, so this is an example of how you could do something in an if loop, or an if statement. So we have if and then a condition, and then a preceding line of execution if the condition's met, and then a false case on the condition. Ternaries are super close to the same thing. We have our condition, and then question mark, and then what we want to do in a truth case versus what we want to do in a false case, split by a full colon. And so this saves us a ton of bytes because we don't need the words if else, and then we don't need to wrap a condition. And then, I mean, that's really the only bytes that we save between the two, but this is like 6 alone, and then 2 here. And then the 2 could be traded out for this colon and the question mark. So really you're saving 6 bytes most of the time. It depends on what you want to do within these. Sometimes you save more because ternaries can be really smart in how they evaluate the truth. So you could say something like, we'll go back to the example, 0. And basically this is saying add 1 to x if t is true, otherwise add 0. And like, I guess you could just say, oh, that's the same number of bytes. Okay, let's say this happened though. Then it's like, now you've got to have an else clause, and then you have to say, like, that's just too much code. This is just too many bytes. I guess you could jump this new line. But this plus equals sometimes will fix, it will allow you to reduce code in a really interesting manner. Like this doesn't seem like it's ever appropriate because it doesn't even make sense. But in CodeGolf, nothing ever makes sense. So you just do whatever. So we'll go to what this one, oh, this is exactly what the example was. So if t clause x plus equals 1, otherwise x plus equals 2, you can save a ton of bytes by doing this x plus equals. Okay, so the final big thing that people that are new to Code Golf won't see often is the ability to manipulate global space for variable declaration and the ability to manipulate default variable types. And so one example of this would be like int main argc is actually legal. It will just default argc to be an integer value. And so usually you'll see functions require types to be put, just like you usually see functions require the type that they're returning, but main's kind of special. It has a bunch of defaults. And then the second thing you can do is make a variable in the global space, and it will also default that to an integer value. And so integers are kind of a special, like, used often type. And so I think the reason they default to that often is so that if you're quickly developing something and you forget to give it a type, maybe GCC is a little lenient and allows you to default type to integers. This can break if you didn't actually want an integer, but for the most part, integers are all the only type you usually need is an integer and a character pointer. And if you're not dealing with strings, then you really only need an integer. Even if you are dealing with strings, you can do it one character at a time. So usually, most of the time, integers are all you need. Okay, what else did I say here? Main args, that's another good thing to think about. And then starting values really do matter. So if you instantiate x within a global variable scope, it'll initialize with a value of 0. And then if you initialize it in main scope, then it'll probably have a random value. And then if you initialize it as that argc value, then it will probably have the value 1, depending on how you're starting the challenge. And most of the time, there's no real lenience on, like, if I really wanted x to start at 10, I could do, and this would give me an x value of 10. But this is kind of, like, I think this is in a way cheating, because the real hope is that your code is doing all of the work. And in this case, you're forcing the user that's starting the code to give you kind of a boost. And so, I don't know. If you can do that and it beats Logan, then that's probably fair. But otherwise, that should be cheating. If it's used to beat me, then that's cheating. Okay, what else? Okay, I think that's all that. So here we've got an example of, well, that's not even legal. See, I don't know why I wrote that, but where you can have x start at 0 without needing to declare a type or giving it a starting value. And I think that's all for that one. Okay, some final notes. Functions to use, I really don't recommend using things like scanf and printf, just because there's always more efficient ways to do things. Like scanf will return, okay, just as an example to show why scanf isn't that good for Code Golf. Scanf is great, and printf is also great, but if we look at, does it not even have it here? Okay, so on success, these functions return the number of input items successfully matched and assigned. If the end of input is reached before you read in something properly, EOF is returned, and that's like way more inconvenient to deal with than if null is returned. So if you look at read will return the number of bytes that you read. So the number of bytes read is returned. So if you hit the end of your input buffer and you have to deal with an end of file versus a 0, it's way easier to say, like, no, don't use while loops. We've already discovered that. While read, and then your read parameters, because this will return 0 once you stop reading successfully. So we would say something like 0 buff 1, except the name of our buffer would not be buff because it's too many characters. So like this is way easier than using scanf, even if scanf is generous in how it's returning types that we care about. So most of the time, it's probably simpler to do this. If you really need to read an int, then you're going to have to use scanf probably. Unless you have a crazy like get char into, converting to base 10, but that'd be probably a little bit more work. If you know that it's going to be less than 10, you can just do, or if you know it's going to be less than, 10, then you can use get char and subtract the 0 ASCII value. But for the most part, that doesn't usually happen. Okay, I think that's all for the functions that I wanted to talk about. Similar with gets and puts, like gets and puts are really, puts adds a new line, which is really important because you don't need to add the 2 characters for the new line at the end. So that's really nice. And then gets is really nice because it's just really nice. It's just so few characters, and it can read in a full buffer to a new line. And I think that I don't know what it returns on fail. I don't think this is as easy to deal with. Return value gets... Oh yeah, it returns a... It also returns the character pointer that you read into. Interesting. But then on fail, it may not. Yeah, null is on air. So that's really nice. That's another reason to use gets. So it'll return the character pointer that you pass, or if it fails, it return 0. So that's also a really nice function to use. And then strlen. Yeah, those are really it for the functions. There's a lot of things you can use, like a2i, if you think that it's going to be easier to read in a buffer than an integer. I can see that could probably work sometimes, just because a2i is so few characters, or so few arguments that you can just pass it a character pointer and then it returns an integer. Like if you were to do, like I would not recommend doing I to A, because I to A or scanf, or I mean sprintf, both of those require 3 arguments to be passed, and so I mean you're padding out your characters just with the commas you've got to use between and a lot of other things. So I to A seems like it'd be a little bit more difficult to use. Okay, that all sounds pretty good. What else do I have? Okay, this is an example of a string reversal. So basically what's happening here is, instead of mallocing a character... Okay, yeah, a lot of this is really bad, but it takes up a lot of bytes to say something like character, oopsies, A, and you want it to have 10 things. Like, that takes up a lot of bytes. And you can't use... Okay, so like, let's say you've got this notation where you're referencing a character pointer and you're subtracting it along to where it points. Then you can't actually do this if it's an array, because the array pointer needs to stay statically set. You can't actually adjust the what an array character pointer points to. If you instead treat it like a character pointer and then you malloc it, then you can move it along like this. It's got a lot more freedom to how you can adjust its pointer value. But mallocing takes a lot of bytes too. So instead, I create a global variable A, and then I have the character pointer point to A, and then I walk backwards in the global space, reading in 1 byte at a time. When this finally fails, or when I get a new line, so whatever I'm currently read in is not a new line, then I keep going, and then at the way end, I print what the string is at the character pointer plus 1, because the character pointer at the current location would be the new line, so I want to go one further. So this is I think this was the best non-recursive solution that we came up with. And then we had, recursion. So This is like the S tier big brain code golf level of development. So something that you can do that isn't usually thought of. We can go make a new one. So functions can. Well, I won't give that much detail to how recursion works, but functions have the ability to call themselves, and main isn't barred from calling itself. So if you were to make a code file like this and compile and run it, you would get a stack space error because there'd be so many references to main being pushed on, or so many references to the return location of main pushed onto the stack that you'd run out of memory space. So you could then maybe say, let's say you had your argc, and you'd say argc -1. Then, and you could say if argc is actually a value. Now this is like closer to, like, this could actually do something a number of times that you could control, because you could say, here we could give an example. And printf sucks, but in this case, just for testing, you can use it. Let's see if this even. Oh, did it actually come out? Oh, it did. Okay, so we can add things to the, to the command line, and then it gives us a countdown. Because basically what's happening is main is calling itself with a parameter of 1 less than it was called with. Because libc start main is going to call main and tell it this is what was given on the command line. Like, it gives it a reference to the command line arguments. And so when we call ourselves, we are decrementing our value. And then at the way end, when we like return all the way back, then there's nothing else that main's doing. So it's sitting waiting for here. The first stack, the first iteration of main, which is sitting on the stack for its return, is also sitting here. So like, it doesn't do anything afterwards. So we just get this countdown effect of printing what was passed to us. So you'd think that wouldn't be that beneficial, but that reverse string example that I showed was actually significantly better when written like this. And so basically what this is doing is it's starting main, and then while the argument passed to main isn't a new line, we're going to, because C uses fast operators, so if this were to fail, then it wouldn't even do this next step on this $ampersand. But basically what we do is we call ourselves with a character that we're reading from the input buffer. So we call ourselves with that. And then afterwards, we printf the character that was passed to us. And the reason, I think, in this case, why we had to do printf instead of putchar is because it was saving bytes. Because because of what putchar was returning wasn't making this if statement continue. And so, or this for loop, or it's not even for loop. What? I don't even remember the reason. I think the putchar just ended up being more characters. And so this printf will print out whatever was passed to us. Oh, I think it could have been the fact that putchar was trying to print the one that was passed originally. I think that's what was happening. And that's, I mean, if you're trying to reverse a string, the last thing that will be printed is what the first main has as I. And putchar was attempting to dereference 1, or to print 1 as if it were a character, and I think it was failing. And so that's why we had to change to printf. But this was, the recursive solution was significantly better. This was originally all written by Logan, and it was way fewer characters. Most of the time, recursion doesn't seem like it's that beneficial, but in this case, it just happened to kill the competition. It was really good. Okay, what else do we have? Okay, binary math is really important. You can basically, if you're ever 1 byte short on your goal, there's probably a binary math equivalent to an operation that you're conducting. So here you could just say while I is not equal to, or you could say, or in this case, it's actually just saying if I is not equal to, or you could say I XOR 10, because if two things are equal, then their XOR value will be 0. I guess that's the only example I've got for that one. Oh, and then same with binary AND versus a logical AND. In most cases, if you're looking for two conditions and they're both integers, the binary AND will do anything that the logical AND will do. Basically, just because if there's either of them have any bits set, then both of them act identically. And if they're both integer types. This one's pretty common. I think for the most part, people, I don't know why I used a while loop. I'm crazy. The condition that a variable is set and the value is null or 0 will quit out of loops or if statements. And so you could treat the variable as something that's always got to stay greater than 0, or you could just say, well, it's anything that's not 0, and then you save 2 bytes. Because it will, I mean, even though code golf can be pretty janky, operations still happen appropriately. So once it hits 0, it won't be treated differently because the code is written so poorly. Okay, so we're going to do a quick example. I'm not going to like extreme code golf this, but I've got, wait, did I not make it? Okay, so we've got this statement. We'll full screen this. Okay, input a number on command line, print if power of 2. So basically, we're not actually going to do command line. Yeah, command line would involve too much other boring things. So we'll just say read in an integer from a user, and then print if it's a power of 2. So we'll say, we'll call this one golf.c. We'll do all of our standard things. We're going to have a scanf call to get an integer, which is pretty sad, just because I didn't set any limits on what the integer could be. And so that'll make things a little bit more byte heavy. So we'll make our x variable, we'll scanf, oops, into this x variable. And then basically what we can do is say for int I is equal to 0, I is less than, oh, I guess what we could do is we could say, here, we'll write it as if we were writing it the first time, while x, and then we'll have this condition, and we'll say it's true given, like any starting x value, we'll say it's true. And then we'll say if x mod 2, and we're going to say, well, this is greater than 1, by the way. If x mod 2 is equal to 0, or actually, if it's equal to 1, then con is equal to 0, and then we'll say x divides equals 2. So basically what I'm saying is keep cutting x in half, and then if there's ever a point where you cut x in half and it's not a multiple of 2, then that means we're no longer a power 2. Another way to do this would be to say something like int start is equal to 1, while start is less than x, start times equals 2. And then you could say if start is equal to x, then we're good to go. Basically what this one is doing is building up to x instead of breaking x down. Either one would be fine, but we're not going to stay too long on this because there's a slightly cleaner version that we can write anyway. Okay, so then we'll say something like printf. Actually, we can do this instead. We'll do one cheeky thing. So we'll say cond, then we'll say yes. Otherwise, we'll say no. Okay, so this will probably break on 0, since technically 0 is probably not considered something to... Oh, oops. I want to golf. So we'll give it 2, it says yes, 3 says no, 4 says yes, 5 no, we'll go to 8, 1024, 1. Okay, so I think on 0 it's going to say yes, and then anything that's negative it says yes. We won't worry about that because that seems like too difficult. Like code golfers don't need to worry about all of the cases. Okay, so let's start to... Oh, and then we can do something like WC on golf. And we can see that we use... Or actually, we can just do -C to make it simpler. We use 166 bytes. So we can cut that down a little bit. So we know that ints don't matter. We don't need to include anything. Let's make this X. We're going to read into it instantly. So we actually save bytes by putting it there. Then not worry about that. Cut all that out. Okay, so we've got this condition. Oh, also we have a space here. What are we doing? So we've got this condition. We could for now keep it, and we could just put it here. So that's going to start it at 0. So now let's change this to set it to 1. Oops. And then let's change this to say just that. And let's get rid of those because you don't need those anymore. We could change this to a 4 because we know that 4s are better in all circumstances. We'll probably still need this to be divide equals 2. We could do something like, but then we'd have to do that. And so divide equals 2 is probably just the best way to do that. Okay. So we change this around. So now the condition starts at 0, and then it moves to 1 if we fail. So we're going to have to say now print no here. And this just saves us bytes because then we don't need to instantiate it. And then everything else stayed the same number of bytes. Okay, we kept this on the end. I don't think we need that anymore. Okay. There's probably something broken in there, but we'll find out. Okay, so we accidentally kept the scan. Wait, what happened? Thank you. Oh, you're right. Okay, so the way, since we did, okay, here's another, thank you for pointing that out because this is a cool trick. So let's say we've got our for loop. So this would require either we have a single line that incorporates all of our statement, or we wrap it in curly brackets. So instead, okay, and so that would be the requirement of the for loop. Similar rules follow for if statements. So what we have right now is we have this if x mod 2 thing, so we can only have one line here, but then we've got another line for the for loop. So this is where our ternary will really help us out, because we could say something like x mod 2, question mark, okay, then c equals 1. And instead of doing even that, what would be a better way to do this? Okay, so we could instead say x and 1. And that's saying is that first bit set? Then don't do anything, otherwise c equals 1. You can't have this, like, this area right here can be empty, but this area can't. And I have never learned why that is. It's because of left value operand dereferencing or something crazy, but I think it's still stupid. Okay. So, oh, actually that's still going to be annoying. We might just have to wrap it in curly brackets for now because I don't want to waste too much time. We'll just wrap it in curly brackets. But remember that ternaries can be convenient for rules of the ifs. Okay, we'll do that. Okay, so we give it 4. It says yes. 5, no. Let's see. 65,536. 65,537. Bingo. Okay. So we're good to go. It still probably says 0 is yes and anything negative is yes, but whatever. That's fine. Okay. So now let's look at something a little bit more nuanced. So we could, after some observation, we could look at the binary structure of what powers look like, and we could see that they look like this always, because if you're looking at the binary notation for a value, you can tell if it's a power of 2 really easily, because it will have only one single 1 anywhere. And so we can actually use that to our benefit. So we can say something like, so if we think of 0, 1, 1, so this right here is the value of 4. 4 minus, or 4 ANDed with 3 gives us 0, because there's not a single bit that stays the same. And that's only ever the case if you're 0. Well, actually, if you're 1's complement and you're 0. Or if you're a power of 2. And that's simply because your bit that's set switches to a 0, and then everything else less than it flips. And so we can abuse that pretty easily. So we can say we still need to scanf. We no longer need this. We scanf this x. We say something like, just get rid of all that. X and x minus 1. Question mark. Wait, that's not what we want. X and x minus 1. I don't know if how that would work. If this x minus 1 needs to be in these. If it does, then we'll find out, but and that's actually in the correct order too. So we'll compile it and run that. 4 we get yes, 5 we get no, 7 no, 8 we get yes. So what we're doing now is we're abusing an element of the binary structure of a power of 2. So this will still break. I'm pretty sure if you give it 0, it'll break. But if you give it 1, it still succeeds. But then if you give it negative values, it's dependent on the 2's complement binary structure of those negative values. So in cases where it's like 37, I don't know what these would look like actually. Oh, that would not even be close anyway. Yeah, you'd have to, it'd be like a really, really big negative number, which would be really close binary structure-wise. Like negative 0, 0. Okay, anyway, it just depends on the binary structure. Okay, and then this one ends up getting to 48 characters. So we cut it from the 166. So we really improved pretty significantly. Okay, that's all I have for the demonstration and content. I wanted to show off, I don't know if this is actually the site. Oh, it is. Oh, this is the beta site. Logan, is it just codegolf.net? Okay, we'll just stay on this one. This is fine. Yeah. I guess that's how it works. Oh, there you go. So, okay, I forgot that I had to keep saying words. So this is a site that Andrew put together, and Logan's been working on like a new version to come out soon with a little bit more involved challenges and some new languages. Basically, there's a challenge that will go out on the site. I don't know when the last time this was updated or when the last challenge was released. Basically, you have to write a solution that would solve the challenge and then use the submission script that's included here. It will basically bring in your solution and then post it to the site that's like the API that's looking for submissions and then compiling it and then testing it against correct output. Yeah, that's all. It's really fun, and there's a significant potential for learning some really cool things. And there's a lot of good competition usually. There's some cases where like just single responses from the challenge scenario will give you passes. So if you just did like puts and then positive, you'll probably get it right at some point. But I think that's being adjusted in the new version to test multiple challenge scenarios so that you can't cheat. Okay, that's actually all I have now. Do people have questions about Code Golf, or if you are wondering if there's ever like a practical use, there's not, but like you can learn things about the language that you become very practical later. Like ternaries are actually extremely nice, and they make a ton of sense to me, and I didn't know about them before using them all the time, and so there can be benefits, but it's usually not that obvious. Also, there's a lot of forums where you can go out and make fun of people if you make a submission that's better than theirs. There was one forum that had a prime number solution, and the guy thought he was like a legend, and I cut it by like 6 bytes, and so pretty cool, not gonna lie. It's whatever. Okay, I'll take the lasting silence as nothing. Well, I hope this was at least somewhat entertaining. If you have any questions, you can reach out. I really would recommend you go to the site. Just solving the challenges without having to code golf it is beneficial. I think it's usually a lot of fun, and you develop your ability to problem solve, and so